Graph the equation by hand that passes through the point 0, 4 and has a slope of -2. So we have some information about the line that we're going to be graphing. We know that it passes through the point 0, 4, and that's not just going to be any old point on our line, that's going to be the y-intercept. And we know that because the x-coordinate is 0. Remember, whenever we have an x-coordinate of 0, that means that that's going to be our y-intercept. Now we also know that we have a slope of -2. So once we take care of our y-intercept, we'll circle back and talk about this slope. So our y-intercept is 0, 4. So from the origin, we go 0 in the x direction. We don't go left to right. We just go straight up to 4. So there's the point 0, 4. That's going to be our starting point for our graph. So that's going to be one of the points on our graph. Now we have our slope of -2. And so remember that the idea of slope is this idea of the rise over the run. That's how slope kind of breaks down. But notice that it's a little bit strange because they just told us that the slope of the line is -2. So I'm wondering, well, is that the rise? Is that the run? How does that work? Remember that anytime we have an integer, a nice tidy number that doesn't look like a fraction or a decimal, we can always just put that number over 1 to turn it into something that looks like a fraction. And so that's going to be really helpful for us here because we want to have a value for both the rise and the run. So by putting this 1 here, that tells me that my run on my line is going to be 1 for every rise of -2. Be careful on your signs here. We know that we want the slope to be -2. That means that the run has to be a positive 1 because a negative divided by a positive is a negative. That's going to give me my slope of -2. Notice that if I had written -2 over -1, -2 over -1, make that 1 a little bit clearer there. Well, negative divided by a negative is a positive, and 2 divided by 1 would be 2. And that's not the slope we were looking for, so that's not how we want to do that. When we're dealing with a negative slope, that negative sign can only go in one of the two places. It can only go with the rise like we did it here. We could also put it only with the run and make the rise positive, but that would be a little bit weird in this situation. So let's go ahead and use our slope now to come up with a couple more points on our line. So we have -2 over +1. So from the y-intercept, not from the origin, but from that point, that y-intercept that we plotted, we're going to rise -2. So the rise has to do with how we're moving on the y-axis. We're not going to be going in the positive direction this time. This time we're moving in the negative direction. So we're going to be going down. So we're going to go down 1, 2, and then we're going to run +1. So that means that we're going to be moving to the right 1. And then we can do that again. Rise of -2 and a run of +1. It's not a bad idea to do a couple of these because remember we're going to want to be putting our straight edge down. And the more points we have, the more accurate our line is going to be. So let's just do one more. We can do down 2 and over to the right 1. Now, something that I want to show you on a problem like this, remember that I had said that we could put the negative in the denominator down here with the run if we had wanted to and make the rise positive? Because it's true that +2 divided by -1, that would also give me my slope of -2 that we saw from the original problem. That also gives me that slope of -2. Doesn't that give me a different line? Notice how that works out. If we go back to our y-intercept and we use this idea for our slope, if we rise +2 and we run -1, so running in the negative direction means we could be going to the left because we're moving in the negative direction. Notice that would put a point right there. And that's going to be right on the same line as those other points that I found using -2 over +1. I could do that again, rise +2, run -1, and that still puts me on the same line. So it doesn't matter if your negative is in the numerator or if it's in the denominator, as long as it's in only one place. You can't have it in both places like we saw here because that would change it into a positive slope. Let's grab our straight edge and get our line on here now. So there's our straight edge. I'm going to move it and line it up with this top point right there. Just going to line that up. Now I'm going to grab it and rotate it down so it goes right through the middle of those other points that I plotted. And be as accurate as you possibly can be. We know that we're kind of working with some crude tools here, but we really want our graphs to be as accurate as they can be. Now we're going to draw our line through all the points. So start down here, and there's going to be my line. And now I'm done with my straight edge, so I can get rid of that. And then the last thing to be sure to do is to put arrows on your line. Remember, that shows that the line continues forever. It doesn't just start where your pencil started and stopped where your pencil stopped. The arrows show that this line goes forever and ever and ever. And there's our final graph.